It's posted in the newest message on Software Robot. So let's go ahead and get started. So as you know, Java runs code basically in the order you call it, and it creates a call stack where basically it's just gonna do things in the order they're told to be done. When you call a method, it's gonna go back to where that method ended. But then what if you want to do multiple things at the same time? Now, there's not a lot of languages that can't do this, but Java can, and that uses this thing called threads. So when by default, you're just running everything in the same thread. But if you want to have multiple things running at the same time, then you can create another thread or multiple threads. So you can kind of think of, here we have two threads here. We have the main thread, and then we created a new thread off the main thread. And the code won't complete until both threads are done. So any code running on the main thread is going to have to wait until the new thread is done. And apparently the new thread is counting from 1 to 5. So this might take 5 seconds to complete. So here is an example of how to use a thread, which is, and Daniel, if you have anything to add, please let me know. So basically a thread, you can make a thread and have it run something, and then I'm not completely familiar with these thread.start, thread.join, but I'm assuming that that would start appears to be starting the new thread, and then join is waiting for the thread to finish, and then it'll move on in the main thread. So when are threads useful? When you need to do something in the background that's going to take a while, but you don't need to, and you also need to do other stuff at the same time. So so thread.join pauses. Okay, so thread.join is what I thought it did. It will pause the thread that you're calling the other thread from within. So if you're in the main thread, it'll pause the secondary thread until the secondary thread finishes. Hold on a second. And then thread.sleep will literally pause the code for a certain amount of time. And there are often better ways to do that. Like in robot code, for example, you probably would never want to, you really don't want to use a thread.sleep, especially in the main thread, because that'll literally shut everything down. And then So then, and then start will start a secondary thread. That's okay, Suvrath. We can talk a little more when I get to the end of the slides while people are working. And then if you, and then you can always go back and look at the recording later. So, let's do some practice in the, I think this is just the same thing that's on REPL right now, but I might be wrong. Yeah, it's the same thing that's on REPL. So just copy that and then make a new file in your folder. If we have some problems with that, then we could also try some doing like, I can have multiple people sharing their screen at the same time or something like that. So this is what you should be copying into your own file. Oh, oh, are you guys unable to create files in your folder? Okay, basically, here's what we're gonna do. I'm gonna stop sharing, and I'm gonna turn on the thing that lets multiple participants share simultaneously, and basically just share your screen from wherever you're working. Then I can go around and see it. Does that sound like it'll work for everyone that had trouble? So just when you're ready to show it, you can put up your check mark and share your screen, and then I'll be able to switch between them. So you can therefore do the work wherever you want, and you can do it in IntelliJ or in REPL or wherever you like, as long as it works. Okay, how many of you are confused about what I just presented about? Put up a check mark or an X if you're confused about what I just talked about. Okay. So let me put the presentation back up. Daniel, do you have any ideas for how it maybe could be better explained?
Give me a second. I'm going to share my screen so that I have control over the slides. Give me a second. All right, so we've gone through it once, but let's go over it again so you guys understand. So thread and synchronized. This. Okay, so threads and synchronized. So what is a thread? As Grady said, a thread is kind of like a secondary process that you can run code in. So normally when you write code in Java, it's going to run like in a list. When you look at the main method, which is where things actually run, it'll go in order like first thing, second thing, blah blah blah, and it keeps on going. But like let's say you want to run something in the background. Um, well, you can't really do that like using just the main method because everything's going to run in order. You can't really do things simultaneously, or like, let's say you had a really big calculation that's going to take a really long time. Your code is going to have to wait for that entire calculation to finish before it can continue, and that's really time consuming. So what we can do is create a thread. A thread is pretty much like a separate process that can run independent from the main code. Think of it like opening another browser tab. You can do stuff in the other browser tab without affecting like your main tab that you already have open. And then you can create multiple tabs or threads, which can do a bunch of different things at the same time. All right. So that's what this diagram is showing you. So we have the main thread, which is like running this, the stuff that you actually want to get done, all the main code that you're writing. But then we have a separate thread that we want to count from 1 to 5. Obviously, we don't want this counting from 1 to 5. We don't want the entire program to wait for it to finish counting from 1 to 5. That's really time consuming. We want to do other things while that's counting. So we're going to put that into a separate thread. So then we can write code that says, okay, wait for both threads to finish. So wait for the main thread to run all its code and wait for this separate thread to run all its code. Actually, let me. Okay, there's no little pointer thing. Oh, there is. Okay. So once this separate thread finishes and our main thread finishes, then we can say our code is complete. All right. So how do we make a thread in code? So first things first, a thread is a special type of class. If you remember from inheritance, to make a thread, you have to inherit from the thread class. It's something that is already in Java. So in this case, when we're looking at this code, we're creating a new class of a type thread, which means it can run separately from the main thread or the main execution, whatever you want to think of it as. And when you extend from thread, you get this nice function called run. Run pretty much means to start the new thread. To run like to just take this thread that you created and start running it in a separate process.
Can I jump in? Run is like the main method of the new thread.
Yeah, exactly. It's the main method for a thread. So in this case, we're going to, I believe this is just going to be printing out the numbers from 0 to 400, 4,500 and 500. It's going to print out a number and then it's going to wait 1 millisecond, I believe. And then it's going to keep on doing that until it's done. And then over here, we have another example of a thread. In this case, rather than creating a complete class, like making a completely new class that extends thread, here we just make a new thread object. And just make a new instance of the thread class. So it's kind of like using the thread type, or in this case, we're using the thread class that we just made. So we create a new object, new variable of type myThread. We're going to name it thread, and we're going to create a new thread using the default constructor. You should remember that from when we were talking about classes. So we start by printing out starting thread. So this gets printed out. Next, we start the thread. So thread.starts pretty much begins running the thread. And what it does is it runs this run function in a completely separate process. Java does the backend stuff for you. Just know that when you say .start, it starts this run function in a separate process. So then this code runs, and we can see that here, where we have like the 0 through whatever. Then we have system.out, print line, waiting for thread to finish. So that gets printed out. Then thread.join, pretty much it's saying, okay, wait, have the main thread. So the main thread is, literally the main method. Have the main method wait till the thread is complete before continuing on. So we print out waiting for thread to finish. Then it's going to wait till this completes. So it prints out all the numbers. And then once that completes, this tells the code, all right, the thread is done. We can continue now. So it goes down to system.out print line thread finished, and it prints that out. And then that's the end of the process. So if we go into the uses, as I just said, threads are really useful if you have to do something in the background. Like let's say you have to do a bunch of math in the background that takes a lot of time. Like, I don't know, you have to take the integral of some graph. And you can't really have the program just wait for it to be done. You can run that in the background. Other uses are like web requests, like when you go into Google Drive and you like do the thing where you refresh the things in your Google Drive. Well, obviously you don't want the app to suddenly freeze when it refreshes. So instead it runs the refresh request, or like the process to retrieve the files in your Google Drive in a thread so that you can still interact with the app while it's refreshing. Complicated path trajectories, that's getting into robot code where we have the path generation in a separate thread. That way the robot doesn't stop functioning when we're trying to calculate a new path for it. And then uh, and then like these processes can like take up a lot of time. So we really want to like put this into a separate thread when we can. So useful methods, as I just said, there's thread.join, which waits until a thread is finished before continuing on. So it's pretty much saying like wait till thread is finished before continuing. Thread.sleep is pretty much pausing a thread. So it's pausing a thread for a certain amount of time. So pretty much it's just like a wait function, just saying like, hey, wait a certain amount of time before you continue running code. And thread.sleep is in milliseconds. That's important. It is not in seconds, it is in milliseconds. So, and then finally we have thread.start. And as I've just said, thread.start, it just starts the thread. All right. So hopefully that clears some questions up for you. Does anyone have any questions? You can pop it in the chat. You can unmute yourself and ask. So then is everyone good? Give a little green check mark if you understand everything. If you still don't understand something, give a no. All right, cool. So now that you're filled in a little more, try to do the thread.java practice in REPL.
Or not in REPL. REPL seems to be, I think it would work better just to have you guys simultaneously screen share when you're done.
Okay,
So if you want to do it in REPL, do it in REPL. If you want to do it in IntelliJ, do it in IntelliJ. If you want to do it, just do it in a Java editor and screen share your screen. It should let everyone screen share at the same time when you're done.
Okay, so as Grady said, just do the code wherever you can find it, and once you're done, give us a check mark, and then we screen share it so we can check it.
And Daniel, you will have to stop screen sharing to be able to see
Yes,
the
I am aware.
spreadsheets.
I am stopping.
Which is so unintuitive.
Samra, just share your screen now and we'll check it.
Oh, and when you guys are screen sharing, you really only need to share the thread underneath, because we know what the um um superclass looks like. And yeah, and we can take you to a breakout room. Daniel can take you to a breakout room or something. Some of it, we're going to be going, everyone, we're going to be going over runnables after you guys finish this activity. So no, it's not the last thing we're doing today. And so yeah, if you have questions, if you want to work one-on-one with Daniel, he can go into a breakout room with you, or whatever. Just make sure you let us know and show us your code when you're done with it, please. Yeah. So can you guys put up a, or can you guys write in the chat how many more minutes you think you need? If you're not done. So Suvrath, can you please oh, hold on. Let's see. So let's see. Look, Brendan, Marco, Samir, Vineet, and Wendy, how are you all doing? Daniel's in a breakout room. So, let's see. So no one who actually needed more time answered last time. So can you, except Brendan. Brendan, how are you doing now? Okay. Um, okay, cool. When, and then Wendy and Samir and Vineet, how are you guys doing? Okay. So, how about, can Vineet and Brendan, can you guys both, would one of you be willing to explain how it works and share your screen, and then the other of you can just share your screen? Okay, Brendan, can you please put up you can share your screen and talk about what everything is doing. And then Vineet, right after Brendan's done with that, I'll just let you share your screen so that I can see your code.
Can you see it?
Yep, we can see it.
Okay, so basically here, this is the main thread, the main method basically, and it's declaring a new thread here, and it's printing starting thread, and then it starts it, and then goes down here. And it's creating a new class called myThread that extends thread, and here's the method for the new thread, and it's just a for loop that prints out the integer that it's counting towards, and then it just sleep for 2 seconds, and then it goes back through it again until it hits 5, and then it'll catch it and return and join the thread, and then print out thread finished.
That looks good. Vineet, would you please quickly share what you did? And then we will move on to runnables.
Oh, can you see my screen?
Yeah.
Yeah, so I made it a for loop, and so it iterates all the way through to number 6, and it'll print out the number that is being run in the loop. And as you can see, thread.sleep sleeps for 2 seconds after each number, and it ends at 6.
Right. And then I'm gonna
Yeah, and the code ran, as you can see over here.
Yeah. So let's see. I just want to, so the point with threads is that, as you can tell, you're not waiting for the thread to finish before you move on in the code, because that print statement waiting for the thread to finish will still print out, even though that is when two things are running at the same time. All right, I'm gonna now go ahead and share the presentation again so that we can talk about Runnable. So, what's a runnable? You can think of I think you can think of a runnable as like a method that you can just pretty much call. It's a kind of a class that you can call. So it's a class that kind of functions as a method, and what it lets you do is do things like take a method as a parameter, at which point the method that takes the method as a parameter could then do something with that, like run it. And then, so runnables are an interface. They contain one method, run, and when you implement them, you just put whatever you want to happen inside there, and then whenever you call the runnable, it runs. Here's an example of a runnable, and as you can see, it is implementing the runnable interface, which contains the single method, the blueprint for the method run, and you just do whatever you want in there, and then when you say runnable.run, it says what was run. There are also, you can also make a thread with a runnable so that when oh wait, yeah, right. So you can make a thread runnable. So up here, we're defining that runnable, and we're doing it all right in the class here. So it's a little bit different from here, but it's all the same. It's kind of has a similar effect. And then we can make the thread with putting the runnable inside, and then use it the same way as we did before. And when we say thread.start, it'll run. So now, were you guys, yeah, okay. Now let's go ahead and do some practice. I don't know runnable. Okay. If you guys, are you guys all able to see that runnable thread example? Wait, no, that's the answer. I want it's under, I don't know where I don't know where the actual prompt for this was.
Okay, so everyone, make a copy of your thread practice.java. You can either create a new file and then copy all your code into it, or something like that. Just make a copy of it, and then in that copy, convert the thread into a runnable. If you can't figure out how to make a copy, then just directly change the thread practice.java and do your do the practice there.
So again, just go ahead and put up a green check mark when you're done. And if you want to talk about it one-on-one with Daniel, then you can send me a chat message. So how are you guys all doing with this thing? Okay. So hold on a second.
Yeah, in a second.
Um, if we saw yours, then you can then yeah, you can go in. Oh, whoa. Okay, Suvrath. Um, um, yes. Same output. Suvrath, I think that looks pretty good. Amrit, can you paste your code in a private chat to me or on in a DM on Slack or something? Yeah, you guys can send it on Slack, share your screen, or paste it in a private chat to me. That one's least preferred because it's hard to read. And if you want to talk it through with Daniel when he's done talking with Yash, you can go in the breakout room with him. So if I've seen your code, you can go. And you can DM it. So Vineet, you're basically converting it to from a runnable. It's gonna be the same output, but you're making it so that it's part of a runnable now. I'm not trying to deal with REPL, so you either need to request to go into a breakout room or send it to me on Slack so that I can see it.